Okay, so we'll be solving quadratics in a minute so that we can factor them and cancel things in rationals, but first just to make some basic practice on quadratics. First thing about a quadratic is you want it to read ... equals 0, and this one does not. So if your quadratic does not equal 0, you want to make that happen. You can take this to the left-hand side where it will become a plus 20, and we get x squared minus 9x plus 20 equals 0. Now we want to factor it. Factoring a quadratic is best done using a process called decomposition, which I may have to use for B, but there's a shortcut if you just have x squared here, not 2x squared or anything like that, but just 1x squared. The shortcut is you want to find two numbers which add up to this coefficient, add up to -9 in this case, and multiply to positive 20. You get those? Add up to -9, multiply to 20. The ways you can get 20 are 1 times 20. Well, those will never add up to -9. 2 times 10 also gives you 20, but those won't add up to -9. 3 doesn't go into 20. 4 times 5, hey, those add up to 9. If we do -4 and -5, those are two numbers which add up to -9, and when you multiply them, you get positive 20. -4 and -5. That means this factors to x minus 4, x minus 5 equals 0. Okay, it's like we're unfoiling this. These are the two binomials which, if you foil them, will give you x squared minus 9x plus 20. So we're working backwards to get here. Now, to solve this, we'd say, if this equals 0, then either x minus 4 equals 0, because then we'd have 0 times who cares what, the result would come out to 0. Or, the other possibility is the x minus 5 came out to 0, because then we'd have some number times 0 here. That would still satisfy this equation. Solve those, which doesn't take long. You get either x is 4 or x is 5. Those are our two solutions. Quadratics can have no solutions at all, or they can have one solution, or the most they can ever have is 2. Now, for B, I am going to have to use decomposition, which is a little bit of a variation on this. I say that because we have a coefficient on our x squared term. That means the shortcut I showed you earlier is not going to work. We have to dig a little deeper. So, the process now is we're looking for two numbers which add up to 13. That part hasn't changed. So we still want two numbers that add to plus 13. But we want them to multiply not to just -5 now, but to 6 times -5. You take the first coefficient and the last coefficient, multiply them together. So multiply to -30. How do we get two numbers to add up to 13 and multiply to -30? Here's the ways you can make 30. 1 times 30, of course. That'll never add up to 13 no matter what I do to the signs. 2 times 15. That could do it, actually. If we had -2 and plus 15, those would add up to 13, and they would multiply to -30. So I believe this is our pair. I was kind of thinking it would be 3 and 10, but this is looking good, so let's run with it. Okay, here's what you do with that. Rewrite your quadratic. Rewrite its first and last terms. So 6x squared minus 5 equals 0. But instead of this middle term, we're going to use these numbers instead. Instead of 13x, I'm going to say minus 2x plus 15x. Use those two numbers we came up with to replace the middle term. This is still 13x. We just wrote it in two separate pieces. This is the part that's called decomposition, which means breaking down. We're breaking down the 13 into two other numbers that we think are going to help us. And now what you do with this is you factor it by grouping. Take the first two terms, factor them as much as you can. Take the last two terms, factor them as much as you can. So out of these two terms, I can take out 2x, and that leaves me with 3x minus 1. Do the same thing to these last two terms. I can take out a 5, and look what happens. 15x divided by 5 is 3x. Minus 5 divided by 5 is minus 1. 3x minus 1 happened in both of them. This is not a coincidence. This will happen every time if you've done the decomposition right. You can take out that common factor of 3x minus 1, and with it gone, what's left? 2x plus 5. That's your other factor. 2x plus 5. And now we have this factored. If you want, try foiling this back out. You'll get 6x squared, check. 15x minus 2x, which does indeed give 13x, and then negative 1 times 5 gives us negative 5. So yes, this really is equivalent to our original thing. It's just factored form. And now we solve this. To get our solutions, we say either 3x minus 1 equals 0, which would mean 3x is 1, which would mean x is a third. Or we take the other piece and we say 2x plus 5 could equal 0, which would mean 2x is negative 5, divide by 2, and you get x is negative 5 over 2. So again, this quadratic has two solutions. So the first one, we were able to use a shortcut where you just add up, find two numbers that add up to our middle term and multiply to our last term. For this one, we had to use our most powerful method, which is decomposition, where you have to find two numbers that add up to your middle number and multiply to first times last.